right. No. Joking aside, I think this is my first time at the PowerShell conference in Europe. I had a really good time. It's not over yet, I know, but yeah, I hope you did too. So in the next 45 minutes, we're going to talk about Git and GitHub fundamentals. If you've been playing around with Git and GitHub for many months or years, you might not necessarily learn that much in this session, so we're going to cover the fundamentals. When I got started out with Git and GitHub, I'm an IT professional like most of you in the room. I always thought, well, that's something for developers. That's something that they use. Source control. Ugh. It sounds very developer-y. I don't want anything to do with that. But of course, my own understanding of why I need source control changed, but we'll get to that in a few seconds. But my learning journey with Git and GitHub, especially with Git, and I'm sure if you've played already with Git, you will have the same experience. The learning curve is not like this, it's usually like this. So the fundamentals are relatively simple, and those are the fundamentals that I'm going to show you today. But it can become quite complicated, especially once you work together with multiple people, different teams, etc., etc. But nevertheless, it's one of the tools you have to have on your tool belt as an IT professional too, and that reality has changed, I guess. You've probably seen this slide already a few times this week, but nevertheless, without these sponsors, events like these would not be possible, so yay for the sponsors. Thank you very much. A quick note about myself. I'm Thomas Vochten. I'm from Belgium. I'm a technology evangelist. That means I like talking about technology all the time. It's also my job. So yeah, I call myself a PowerPoint architect these days because I do PowerPoints and I talk. That's more or less what I do. I'm not on the PowerPoint team or anything, but yeah, I'm usually on stage somewhere. If it's not for a conference, it's for a customer. And I'm an MVP, which means the same. I like talking a lot about technology. I run a user group and I work for a big Belgian technology company. If you've got any questions afterwards, after the session, or you're stuck with Git, I'm not necessarily the level 400 expert. I'm also still in my getting started journey, even after, I don't know, 4 years of using Git probably. But nevertheless, best way to reach me is probably through Twitter. I'm a fairly active Twitter, so feel free to reach out to me or connect on LinkedIn or whatever. All right. We talked already a little bit about it. Why are we here? IT professionals might consider Git to be something for developers, as I already said. That's not necessarily the case. And all right, developers have all these fancy tools and command line prompts are cool again. We used to have these GUI tools, were fantastic, and okay, you're all using PowerShell, but all the new tool set is quite interesting and quite cool also. Isn't Git and using source control only for developers? Of course not. So that's why we are here. I guess almost everyone is familiar with something like this. Forgive me my ISE icons. I know that's not cool anymore, but that's not about the icons. It's about the file names. So you start a project or something else in your free time. You create a PowerShell script. It works great, and then you say, well, let me change one little thing. But I want to be sure that I can go back to the previous version, so I'll create a copy. That becomes then stuff version 2. Perfect. And you go to a customer, you implement that script or that module, whatever, works great there, but then you want to make a change to the original one. And you use that original one, the changed version, at another customer, et cetera, et cetera, et cetera. And in the end, you end up with a very long file name, like version 25 in production _ at customer A, et cetera. You know what I mean. So we've all been there. Same goes, by the way, for normal files, not just for script files. So we need something to get a grip. And that's why source control is so important, even for IT professionals. Because source control not only lets you work with multiple versions, it also lets you or enables you to go back to a previous version or even work together with different people. Because I stored my PowerShell scripts on my personal OneDrive. I stored them in OneNote even in the past. I'm not really proud of that, or on network share, so other people can take advantage of them. But once you start editing the same files at the same time, you all know what will happen. It can quickly become a horrible mess. So that's what all these reasons are reasons why we need source control. There are many source control systems out there, but I think the industry more or less settled on the default standard. I think it's the de facto standard these days is Git. Git itself has been around for a very long time. It was, by the way, created by the same guy who created Linux, so Linus Torvalds. He also created Git. And rumor is he gave Git its name because Git in English, it's like slang for a very annoying boy. And he's very he knows self-aware. He knows that he is very annoying, and that's why he gave this project the name Git. I don't know if it's really true, but could be. So Git is free. You can download it from the internet. I didn't include the URL. You can Google that yourself. It's open source, so you can look at the source code. But the most important word on this slide is distributed, and that's also what sets Git apart from maybe not all of the other source control systems, but many of the source control systems. There are other ones too, of course. So, but that is more or less what everyone uses these days. If you've been using source control systems in the past, and I've been using a few of them, I wouldn't consider OneDrive to be a source control system, but yeah, let's say OneDrive. I used Subversion, I used, what was it in the day, Team Foundation servers, integrated source control, Visual Source Save, God forbid. All these older, they were great, they had served the purpose, but I think now everyone more or less is using Git. Some key concepts and also a few things that differentiate Git from other source controls. First one, the major keyword is distributed, because that's quite interesting. And also in the beginning, when you start working with Git, it's not that simple to grasp. So what it means is there is no single version. Well, let's say no master version of the truth somewhere. So there is. Every developer, and could be an IT professional, but every developer has their own copy of the complete source code on their PC or somewhere else on a server. And there is also a copy of that same code living on a central repository, what it's called, somewhere, for example, in the cloud, could be on another server, could be on someone else's PC. But there is, the graph implies a certain hierarchical relationship, but that's just a convention. Because technically, all these copies, they are independent of each other. There are links between them, but that's what makes it distributed. To make our lives easier, when we work with such a source control system, there is a convention, and we usually agree that one of these copies, this one, is the one that we all try to push or work to make our lives easier. That's usually something in the cloud, like GitHub. We'll get back to that in a few seconds. But yeah, that gives us a few benefits. Backup being one of them. You're IT professional, so you care about backup. So if everyone has their own source control system on their own PC and the PC gets lost, you know what happens. But if we push all changes to another source control repository, somewhere in the cloud preferably, our code is safe. It also enables us to work together with different people. And that's what this system enables us to do. So all these copies are, let's say, equal. But we all agree that one of these copies is more equal than the others. That's the basic idea. I'm simplifying it a little bit, but to get started, that's all you need to know. Another key concept of using Git is the concept of branching and merging. It sounds like a tree, like a branch, and some source controls also use the word trunk, for like Subversion, for example, so it's all related to trees. What this system enables you to do, and we won't go in that much detail today, we're touching a little bit about branching in my demo, but that can quickly become maybe too complicated for a fundamental session. So what it enables you to do is, in this repository, you have a certain version of the code. This one is called master, but these are just labels. They're also conventions. If you go to GitHub or go to a certain source control repository, you might see things like master or main or root or trunk or whatever, or base, or they're just labels. But a lot of these concepts in Git and GitHub, they are based upon conventions. And many people use master. I use main because it has a less negative connotation, so many people use main these days. And that is the, let's say, we agree that this is the, let's call it the production version of the code, of the PowerShell script. Doesn't have to be a PowerShell script, can be a PDF file or PowerPoint, any file. Those are the production versions, let's call it that way. Now, let's say you want to make a change to something, but you don't want to affect the production copy. That's when you create a branch. A branch is more or less a copy of what you already have. You put that in a different branch of the tree, and you do your stuff there. And what can that be? It can be a bug you're fixing, something you're adding, something new you're developing, a new function adding to your module, stuff like that. That becomes a branch. Now, you might ask yourself, okay, I'm working on that copy, but what if someone on this side changes something? That's when merging comes into play. So even when you're working here on your own new module, your new function, and someone changes something here, you can merge those changes while you're going in your own copy. So you can always keep up to date with the production version. And when you're done, you can merge your changes back into the production copy. So everyone uses the new feature that you've developed. Again, I'm a little bit simplifying it, but that's the idea. You can have as many branches as you wish. You can have sub-branches of branches of branches of branches. Can be very complicated. You can tie that to versioning of your application, of your script if you want. But that's the main premise. In my demonstration, I'm going to create one branch, and yeah, we'll see how that works. Something else that sets Git apart from other source control systems is the concept of staging. If you've used source control systems before, like almost any source control system actually, when you make a change, or when you want to change a file, that file is being locked for all the others. So they cannot, it's like check in, check out, that principle. Git doesn't have that, which is interesting because everyone can make changes to the same file. And then you can imagine that sometimes putting those changes back together, it's called merging, can lead to certain conflicts. That's true. But also in Git, you can choose which changes you are going to commit, how that's called, to your repository. So say you change 25 files, you can choose to only merge one file back into the repository instead of all 25 like in other source control systems. Again, I'm simplifying a little bit. But those are the main key concepts of Git. Git is quite performant also. It's very stable. It's very robust. But it makes it very powerful and therefore sometimes also maybe a bit difficult. And talking about difficult, I'll take a sip of my water and I'll let you read this slide. So it basically means Git is complicated, or can be complicated. And even people who use Git already for quite some time, they're guilty of what this person does here, myself included. And I talked to a few speakers yesterday, people who are way more versed in Git than I am, and they all admitted secretly after a few beers that they do the same. If everything fails, you can always throw everything away and start fresh. You're not supposed to do this, by the way. Git has all the tools available to avoid this. But yet, it can be quite complicated, especially, like I said, when you're working in a team. Now, when I encounter a problem, when I feel the urge to do this, I go to this website. It's a brilliant website, ohshitgit.com. And it's a small website, actually. It's maybe one page with the most common problems that you might see that you have with Git and how to get out of them and how to revert back without having to delete everything. And I should have included the QR code, but yeah, well, you can figure it out, I guess. ohshitgit.com. Very simple, but very, very handy. If you're working with Git, absolutely bookmark this site. Now, if you think the language is a little bit offensive, there is an alternative, dang it, Git. So if you're afraid of forwarding that site to a colleague, there is a better version. And it's also localized in a few languages, I think, last time I checked. So dang it, Git, very, very good. So if you get into trouble. All right, we talked about Git and how Git works, what the basic principles are, but we haven't talked about GitHub as much yet. What is GitHub? Remember when I talked about distributed? how we all agree when we're working in a team that we have one version of the truth which is maybe a little bit more equal than the other ones. That's where GitHub comes into play. Because GitHub is a hosted version of Git. It's exactly the same as you would install on your laptop, but hosted in the cloud on a server. GitHub has many more capabilities than just source control. You have automation possibilities with GitHub Actions. You can do project management, issues, issue tracking, all that stuff. That's not Git, but the source control aspect of GitHub is just Git as exactly the same version as you would install on your PC. GitHub is a Microsoft company since a few years, which was quite interesting in the beginning. So yeah, but I think they did a great job and still doing a great job with GitHub. So GitHub is also a Git version, but hosted in the cloud that we can take advantage of, for example, to put our code to make sure we have a backup. There are other hosted versions of Git available. Many people know GitHub, but there's also Bitbucket, GitLab, Azure Repos, which is also Microsoft, which also has a version of Git, which was there before GitHub. Well, not before GitHub, but before they acquired it. So there are other versions. If your company uses Bitbucket or GitLab, by all means, that's perfectly fine. It works exactly the same way. It's hosted Git that you can take advantage of. Now, we're all geeks, so we like some tools. What do we need? First of all, Git, it's free, so you install it, you Google it, you download Git from git-scm.com. I don't know why it's such a complicated website, but it's where you download Git. It's free. You install it on your PC, and if you're on Windows, next finishing your way through the installation works just fine. You don't have to worry about anything. So that's then you have the Git binaries on your PC. It's interesting because if you're an IT professional, you maybe are interested in, okay, am I installing a service or of some kind on my PC? No. You're not installing a service. There is nothing that will be running in the background. It's an executable, and you execute it when you need it. That's also quite interesting. And then you need some kind of command line tooling. Of course, everyone here uses Windows Terminal. And you can also use GUI tools. Visual Studio Code is the most obvious one because it has very nice Git integration and GitHub integration. But there are also other tools like GitHub Desktop, which I'll show you shortly in the demonstration. And there are many third-party vendors that create Git tools to have a graphical way of interacting with the local source control system you have. In my demonstration, I'm mainly going to use the command line because for me, to understand the basics, that's the best way to get started. You might be tempted to download GitHub Desktop. By all means, do that. But to grasp the concepts using command line here is quite cool. But we're at the PowerShell conference, so everyone already loves the command line. If you're using Visual Studio Code, these are personally the VS Code extensions I install. You don't need them because Visual Studio Code has native Git integration. But these are a few that you might want to consider: Git Lens, Git History, and GitHub pull requests and issues. If you're working with Git, you will probably already get a proposal to install them. Git Lens will give you a line-by-line information box, let's say, of when this line was last changed by whom, etc., etc. Git History gives you a nicer graphical representation of the file history, and GitHub pull requests and issues, well, is integration with GitHub. So these are a few that you might try. And then something else that I also always install on my PC is the GitHub CLI. And I know the words or the acronym CLI is a little bit forbidden at this conference. But yet, GitHub CLI is really a good CLI, so don't be afraid to download it. It enables you to do things that you would otherwise go to GitHub's website for. So, for example, creating a repository or creating a pull request. We'll get back to that. Stuff you can do from the GitHub CLI. Runs on Windows, runs on Linux. That's fantastic. And before we go to the demo, there is one thing we absolutely need to talk about, and that's this. If you see, and also at this conference, if you look at people using Git and all these fancy tools, their screens always look like this, with fancy colors everywhere. And you know what this is. This is a PowerShell module that provides for this. But I'm talking about this line here. You don't need extra tooling to work with Git. If you open a normal command prompt, you can work with the Git commands. You don't need anything fancy, but this will help you tremendously. This is an open source project called OhMyPosh that you probably already hopefully use. And it gives us nice Git integration. So this box here, and we'll get back to the details in the demo, gives you extra information about what you have to do next. That's basically what it means. All the other is eye candy. My username, my host name, the directory I am in, the time. I'm using PowerShell, and this is my battery status. But the thing we're interested in, and that you probably should use, is this one here. This oh my posh. It was a PowerShell module, but now it's an executable. This is absolutely something you need. So if you want to upgrade your command prompt, I highly recommend you to do so. And this QR code leads to an article by the famous Scott Hanselman, which has a nice blog article detailing exactly how you can arrive from a bland command prompt or PowerShell prompt to something like this. So it's nice to look at, but it also serves a purpose. All right, time for some demos. I've got a few reference slides, but I won't bore you with them. Let's see on what we can do. Okay, there we are with the fancy colors. I think that's readable in the back. Yeah. So we're on my computer. I already installed the Git binaries. I'm in a folder called dev. Dev, doesn't really matter. And I want to get started with source control. So what do I do? Everything is already installed. So if I have one directory already, let's ignore that. Let's make a new directory, hello world. We have a hello world directory. Let's switch to the hello world directory. It's a normal directory in Windows, nothing fancy. But I want to use this directory to store my scripts or store whatever document and put them in source control and work with source control. If you're starting out like this, so many people start from Git. I like to start from the command prompt. When you're starting out here, there is a command, Git Init. And Git Init will make the current directory source control system. Just like that, automatically. So you say Git Init, and we initialized an empty Git repository in this directory. And what you can see is that my prompt immediately changed. See, this is thanks to oh my posh. So it becomes green, and it says, oh, main. What does that mean? We talked about branches. That's my production version of the code. That's my main branch. Okay, and green means good, I guess, and it does. We don't have to do anything special now. So we have our directory, and if you go to Windows Explorer and you look at Explorer, it's an empty directory. There is nothing in it. We made it source control, but there is nothing to see there. In fact, there is a hidden directory, and it's called .git in the same directory. When you open it, you see some kind of files. Never ever, well, you might go there, but never ever do anything in this directory. Don't change it because your source control will not work anymore. So this is the hidden magic where it all happens. So it's included in the directory, but that's just so you know, because we're RT pros, we like to know how stuff works. There is a hidden directory that you have there. All right, about that main, like I said, those are labels. Main is a convention, and you can influence that on your PC by using a git config file. A git config file is a file that usually lives on your home directory, and when you open git config, there is a lot of interesting information, but what we're interested in is this init section here, default branch is main. I could have said Thomas or PS or whatever. It's a label, but I like to use main, but you could use master or anything else. Don't worry about the rest, but that's how you influence this, because by default, I think it's still master, but they might have changed that. So that's when you do git init, you get a main branch. So we looked at the git directory. All right, let's create a file. Well, let's do that in Notepad, and you can see through my PS readline history that I've practiced a little bit. So we want to create a new file in Notepad, yes, and we're going to make a markdown file. Doesn't have to be a markdown file, doesn't really matter. So hello world, because I want to be fancy, markdown is fancy, so hello world. We create a file, we save it, and we have our file there, readme.md. And you can see that immediately the color changed. Because the source control system that I activated says, well, I'm looking at this folder, I see something new, I don't know what it is. That's what happens here. So that's why the color changed. So there's a question mark about one file. If you're ever unsure what the color code and all the icons mean, there is something you can do is Git Status. I use Git Status all the time because Git is quite helpful. It will always tell you what you need to do. So Git Status says we're on the main branch and we have an untracked file. So it's a file, I know it's there, but I don't know anything about it and I'm not using it. So, and it also tells you very politely what you need to do. You need to add it to the source control. And that's exactly what we're going to do. So we add the file. You can specify the name, or if you've got multiple files, you can do star, or different files if you don't want to go with everything. Remember the atomic changes that we talked about. So git add readme.md. All right. Oh, the color is still the same. Strange. But we don't have a question mark. We have a plus now. So, okay, I don't know what that means. Let's do git status again. Git status. Still on the main branch. We haven't done any commits, whatever that means. And we have one change to be committed. That means the source control is watching the file for changes, but we haven't included them, we haven't committed them yet in the source control. We're tracking the file, so we're looking at it, and we know that it exists, but we haven't saved it yet to the source control. That's what that means. So let's do that. So what we need to do is commit the changes that we've done, and that is, you guessed it, git commit. And then you need to specify a message. Always specify a message. Let's do it like this. Always specify the message, and these commit messages are quite essential. Maybe not if you're working on your own, but still, because in 25 months you don't know what a specific commit meant. So because this is my first commit, let's call it I don't know, initial project upload, whatever, some kind of message but meaningful. And we commit it with the message. All the changes that we have pending will be committed to the source control, and then finally everything is green again. Again, if you're unsure, git status. We're on branch main, we're cool. We don't have to do anything. So, perfect. So we have source control, we're in our main branch, and we have a file included in our source control system. Now, what do we want to do? Of course, we want to make a change. So let's open the file again. Too bad Notepad doesn't remember the zoom. And let's say a beautiful weather in Vienna. Something like that. Right? We save the file. Again, could be any file. And if we press enter or do git status, we will see that, again, the color changed. So there is one pending change. Again, if you're unsure, git status. Still on the main branch, we have some changes which are not staged for commit. We haven't added the changes yet. Again, the whole atomic update stuff that we talked about. So you can go back if you made a mistake with git restore. See, it's quite helpful. But we don't want to go back. We want to also save this change to the source control system. So we want to add this change. Again, git add readme. And then we want to commit. Nice weather. And that's a description that you give to this change. All right? So back to green, one file changed. We made 2 insertions. That was my beautiful weather and a new line. If you're unsure, you can always look at the differences, but we'll not go there today. So, if you want to look at the different changes you made, you can always do Git Log, which will give you quite cryptic overview of the changes. We had our initial project upload, and then we have nice weather, the 2 commits I made. And every commit in source control has this unique identifier, and that's the unique identifier you use later on to go back. If you say, oh, I made a terrible mistake, I want to go back to something, that's the GUID that you can use. So, all right. So we created source control, we uploaded the file, we saved it, we changed it, we uploaded it again, and we're green. Now, you can also look at these changes from a GUI. There is a project called GitHub Desktop, which is also a free product that you could use. Let me go to my, all right, here we are. I pre-configured it a little bit, so I tricked you a little bit. Exactly the same, but in a graphical way. We've got 2 changes. We've got initial project upload, where we created a new file and put hello world, and we had another change here when we added 2 extra lines. You can use these kind of tools to look at your changes, but also go back if you want. I don't use GitHub Desktop myself that much, but it can be quite convenient. So something you can do. What you could also do, of course, is open the directory in Visual Studio Code. I hope the zoom will not really mess up. Still okay. So same file, readme the version that we have. You see this kind of information here. 3 minutes ago, initial project upload. That's one of these extensions, that Git lens, that's giving me this information. So if you're unsure, if you're working with 25 people, you can hover to a line, and then it gives you this card which says, okay, when did you change this, and who, and what is the ID, etc. This is not default Visual Studio Code. This is the extension that's doing that. Might come in handy. All right. So. It's beautiful weather in Vienna, but maybe the weather is changing and it's not as beautiful anymore, and we're going to change the file. No, it's raining. We save the file in Visual Studio Code, and you will see in Visual Studio Code it has source control integration. Something happened. There's one pending change, and it says, okay, readme md changed, and if you click it, you can see the change. We changed from beautiful weather to no, it's raining. You can close this. And you can do exactly the same thing as we did in the command line. First, we add the file. You might have multiple files, and you might also only want to include one. We add this. It's called staging here, but no matter. It's adding the file. Stage changed, and then we are going to commit with a message, rain. Control Enter. And it will be included into the source control system. So if we go back to the command line and do Git Log, you will see, nice weather changed to rain. Exactly the same thing. Switch back to Visual Studio Code. This is also some integration. You can look at the different commits here. It's not really nice on a small screen, but you get the idea. So you've got rain, you've got nice weather, but let's say the rain stops and we want to go back to nice weather. You can do that from the command line, but usually reverting changes, I like to do that in a GUI. It gives me a little more certainty maybe, I don't know. But you can as well do it in the command line. In Visual Studio Code, you can right-click the file and then, can say, or revert commits or whatever. There are different possibilities. Let's not go into all the details. And we will revert something so that it will. I shouldn't have done revert actually, but okay. Let's and see my thing is it's a little bit messed up now. I should have gone to file history, by the way. But okay, it will. That's what you get when you, That's what you get when you do a live demo. Come on. No. You see? Oh shit, Git. That's when you use the website. But you get the idea. Come on. We don't want to just changes. Let's go back here. See, so now we have this gibberish here. All right. Okay, so we reverted the change in GitHub, and now we wanna do something with our Git repository. We want to work with GitHub. What you can do is push or upload this repository to GitHub. That's something you can do, but we're going to do that later on. You can also work the other way around if you want. If you go to the GitHub website, and you've got a GitHub, you've got a GitHub account, you can create a new repository here. We created one on our PC, but you can also create one here. Let's call that hello. Okay, so it's created in your account. You can choose whatever name you want. There are a few choices, a private or a public. This is important because it's a website, so everyone can reach it. It's a private repo. You can add a README file if you want. We're not really interested in a README file right now because we already have one. You can also have a git ignore file, which tells Git to ignore certain files. And you can also have a license, which we're not interested in right now. So we create our repository. All right, and then we have Thomas Vochten / hello. It doesn't have to be the same name as the one that you have on your PC, but it's usually a good idea to more or less do the same thing. And then GitHub is quite helpful. It gives you a few possibilities. So what do you want to do? If you know what you're doing, you're just interested in this URL. But if you're not sure what you're doing, and I'm not sure what I'm doing, so we have different choices here. So we can create a new repository on the command line. That's what we already did with Git Init. Or we can push an existing repository from the command line. So if we already have something, we can connect that to GitHub, and everything is synced up. So let's see what we're going to do. Yeah, well, let's not use this one, otherwise I'll be in trouble because of my previous change. So we're going to create a new repository on the command line, exactly the same as we did before: Git Init, Git Add, Git Commit, etc. And then we have a main branch that we already have, and we are going to connect that to the main branch that we have in the cloud. So we can just execute this. Yeah, just paste. No. Just paste everything. Come on. We don't want this. All right. Let me double check. Yes, we're going to init. So more or less the same steps that we had before. And the last line is quite interesting. The last two lines, actually. We are going to add a remote. Git remote add origin. Origin is again a convention. It's a label. And we're going to tell our local source control system that there is another source control system out there, GitHub, the central one, at this location. And we are going to call that origin. And then we're going to push everything we have in our main branch to the origin and to the main branch at the origin. Sounds complicated, but if you get the hang of it, it's quite okay. I'm tethering my phone, so I hope it's quite okay. So, all right. So what we have now in our directory is, who can guess what we will have? A README file, of course. So that's the README file that we created in the cloud. So that's quite cool. Was there a question? No, okay. All right, so we have two repositories connected up. Let's refresh this. What will happen? There is the README file. So both of the repositories are connected to each other. My local copy and the one in the cloud. Fantastic. All right. Let's say I have a colleague, or I'm switching to another PC, and I also want to take advantage of this source control system. What do we have to do then? We are going to clone the repository, which is probably usually the first thing you do when you get started with Git, but I try to go at it from another way. This is my Windows PC, but I also have my Linux PC. This is WSL. I also have Git installed. And let's say this is another PC, and I want to work with this repository. So in any repository that you have this green code button here. And it will enable you to clone, which is taking a copy on your local PC of this repository. So different ways you can do that with the GitHub CLI, which is quite simple. GitHub repo clone. But this is the default way, using the actual git command, and then you need this URL. Let's copy that, and let's go to Linux and do git clone. And to prove you, I have nothing here. I have a few other directories, but not the one we're interested in. Git clone, like this, cloning into hello. Now we go to hello, and then we have our README file. Right, with hello in it. So we have three versions now. We have a version in Windows, we have a version in Linux, and we have a version on GitHub. So distributed, fantastic. Let's say our Linux person here makes a change to the file. Welcome in Vienna. All right. I recently discovered you can also do Control S here and exit, and you see the prompt changed. We're not sure what we have to do, so Git Status. On the main branch, we have a file that has been modified. What are we going to do? We have a staged, let's Git add everything, and Git, I think that was not necessary. Git Commit, welcome to Vienna. Welcome to Vienna. So we're changing this in the source control. And then we have a new color. It's something orange-like. Not sure what that means. Git status. We're on the main branch, but we are ahead. What does that mean? We are ahead. We are ahead of origin main by one commit. Origin, remember, that was GitHub. By the way, if you want to get a list of all the other repositories that you're connected to, you can do git remote -v, and that gives you the label origin and where it points to GitHub. So it knows automatically, well, because we have a new change, we are ahead of the repository in GitHub. So, okay, what we can do now, because we're all clear on the local side, we have to do a git push. And that will push all the changes to GitHub with a little bit of luck. And we're green again. Let's switch to GitHub. Let's refresh. Welcome in Vienna. All right. Let's switch back to our Windows PC. And let's look at our directory. Okay, here's the README file. Let's look at the README file. No Vienna. Okay, remember, distributed. We have to get the changes from the main repository into our Windows PC, and that's something you do with git pull. So it's always this mechanism of git push, git pull, git push, git pull, and all the time. Git pull, and it will look at GitHub, not at my Linux PC, but at GitHub, and it will say, oh, see, I've got one file that has changed, and I made 3 insertions, and now I should hopefully be up to date. Right. Welcome in Vienna. And so every copy everywhere is the same. So the main mantra you should remember is git add, git commit, git push to get it into GitHub, and git pull to get it back down. And then git add, git commit, etc. And that's the whole dance you need to do all the time. Yes.
But if you have multiple persons working on the same repo, would you be able to see that actually things pending for you to be downloaded or fetched?
Yes, you can. Yeah. It's a little, because I don't have multiple users right now, but you can. Yeah. But usually, I must say, I go to GitHub to look at the pending changes. But it never hurts to do git pull all the time. That's the main way of working is when you arrive at the office and you know other people are also working on the code. Before you start doing anything, git pull, and you've got the latest changes, and then you do your own stuff. We're almost out of time. So these are the main things you should know. Usually, when I start working with a source control, I don't create the repository in the user interface on GitHub. I do that through the GitHub CLI, but you get the idea. To finish the demonstration, the organizers asked me to upload the conference files. The conference presentations to a GitHub repository that they have. It's a public one, github.com/PSConfEU 2022. Let's say this is an open source control, an open source system that you want to use, and we want to contribute. We want to publish our presentation to that GitHub repository. But the problem is it's not my repository. I don't have any access there. So I cannot just save something there because I'm not the owner. So then that's when the pull request comes into play. And with a little bit of luck, we don't have that much time left. I'm going to try to do a pull request so my presentation will end up in this repository that I'm not the owner of. What you have to do is create a fork. A fork is creating a copy is basically the same as cloning, but not cloning to your own PC, but cloning to your own GitHub repository, to your own GitHub account. So it's the same as Git Clone, but from a GitHub perspective. So you click the button Git fork, and then you can give a name. Now 2022 is that this is new, you can change this. It's not my preferred name because otherwise I don't know what it is. PSConfEU 22, create a fork, and then it's going to copy this whole repository to my own location. See, Thomas Vochten, PSConfEU 22, exactly the same as we saw in the other account. Now, to add something, we are going to Git again, and this one is where it gets tricky because of the internet connection. Git clone, my own copy, my own fork of the code. I hope this will work, actually. It's always tricky. And I'm already 24 seconds out of time. All right, so we have downloaded everything to our PC. Let's go to the directory. And then we have the same thing. We see a file here, a directory here that I already created. Let's go to that directory. Let's open it in Windows Explorer. And you see, this is for my previous talk. Let's add the files for this talk. Git, GitHub IT Pro. Let's put the PDF file that I've saved of my files there. All right. Let's see what happens. The color should change. Yeah, the color changed. We're not sure what happens. Whoops. Git status. We see something new, right? Again, always the same dance. Git add, in this case, everything. Git commit with a message. Thomas Vochten on Git and Github for the IT Pro. This message will also be shown to the organizers. And again, the orange one, which means we're cool. We're cool here, but we need to push. We need to push to the cloud. Git push. And then my PDF will get uploaded. And then we switch to GitHub. We refresh the page. We're still on my account. You see Thomas Vochten on Git and Github for the IT Pro. If you click here, you can get more information. It's the log, but online. You go to the directory, Thomas Vochten, Git and Github. Here's the PDF file. All right, but this is still in my repository. So that's not exactly, whoops. Sometimes it's a little bit tricky. That's not exactly what I had in mind. But this branch is one commit ahead of PSConfEU main. It's a little bit cryptic, but it means that it sees that I did something new. So what we can do now is open a pull request. And GitHub is very intelligent. So when you open a pull request, it will automatically know which file or which change to go where. So we wanted to have a pull request for PSConfEU 2022 from this repository, and then you have to ask for permission by creating a pull request. And you can leave some comments there. We create a pull request, and now I have to wait for the organizers to see the pull request and to accept this, and then my changes will automatically be uploaded to their repository. That's basically what happens. Unfortunately, I can't influence this further now, so we have to patiently wait until someone sees this change, and then you will see my slides on the GitHub repository. All right, sorry for running a bit over time. Because that's what you have when you do a lot of demos. To finish, something new was released recently, GitHub Skills, a new website with a nice learning path on learning Git and GitHub, mainly GitHub, but also Git, and a link to the Git documentation, which is actually quite good also for beginners. So some takeaways. Learning by doing, start experimenting now, start using the command line first. The best way is the best way to learn. Customize your toolbox. You will be very happy to be using all my Push and all the Git integration. And then remember, commit, push, and pull as often as you can, because that's the way you work together with other people. So, and first and foremost, contributing to open source is easy. For example, you can contribute to the Microsoft documentation on docs.microsoft.com, also through this mechanism. By all means, start experimenting there. All right, sorry for running over time. I want to thank you for your attention. If you've got any other questions, feel free to come up to me and I'll be happy to answer them. Thank you.